Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Keeping track of all the objects in Earth orbit and predicting where they might be at any given time is not a task for humans, but it is a task that AI is very well suited for. Slingshot Aerospace is a company providing satellite tracking, space traffic coordination, and space modeling and simulation solutions to government and commercial customers. Using mission-critical data, insights, and applications powered by the Slingshot platform, space operators improve spaceflight safety and optimize their orbital operations. This common operating picture of space activities, past, present, and predicted, empowers the world's leading space operators to better understand what's happening in space and plan their operations. Recently, Slingshot Aerospace worked with DARPA to create a new AI system called Agatha that identifies anomalous spacecraft within large satellite constellations. The company was also selected last week by NOAA's Office of Space Commerce to build the TRAX user interface. My guest on this edition of the Ex Terra Podcast is Dylan Kesler, VP of AI and Data Science at Slingshot Aerospace. Dylan, welcome to the program.
Thanks, Tom. Thank you for the invite. I'm a longtime listener of your podcast.
Well, thank you. That's the highest praise that you can give me. So I really appreciate that. Let's start off with an overview of Slingshot Aerospace and the mission of the company.
Sure. Slingshot as a company was launched in 2017. We have locations in California, Colorado, and the UK. We have a mission to make space safe, sustainable, and secure. It's a great mission to work for as a company. As a company, Slingshot Aerospace provides solutions to government and commercial partners around the world with AI-powered solutions for satellite tracking, space traffic coordination, and space modeling and simulation. This comes together in the Slingshot platform, which transforms these disparate space data into a common operating picture. We've built an amazing culture of synergy across talent pools that focus on advanced space object tracking, AI, astrodynamics, and data fusion. It's the teams that I work with. And that synergy really supports the platform. This comes together in the platform. We also combine data from the global Slingshot Global Sensor Network, which has 20 locations across the world and more than 150 day-night sensors supporting that. The Slingshot Data database, which supports and documents satellite launches and equipment. It's the authoritative database going back to Sputnik. And we have a data pool from the Slingshot Global Sensor Network, from public sources, from satellite owner-operators and other partners that support what we do as well. Altogether, this allows Slingshot to have a unified representation of space, past, present, and predicted, and to enhance space situational awareness for our customers, to improve operational efficiency, reduce risks to operators, and improve safety.
Now, AI has become kind of a buzzword. Everybody talks about AI. It seems to be in everything. So how do you define AI?
So I've been working with data analytics, data science, and prediction for close to 30 years. And we use the term AI, maybe going back all the way 30 years ago. It's certainly more frequently used nowadays. And I think a few years ago, we really started using it more when we had some deep learning models that were doing some amazing things. But I think the concept of computers performing tasks that normally we would think of humans performing is a through line with the concept of AI. And I think recently, most of us, including people who are outside of the industry, have seen some amazing examples of computers doing just that, behaving and accomplishing things that we might think only humans could accomplish. We see that with some of the things that are available to the public with generative text, images, movie models, ChatGPT, and some of the others. Maybe what's not been so apparent to people outside the industry is the potential for those same sorts of models and technologies to work in very specific areas and to do some of the other things that people might do. That could be in space, it could be in healthcare, it could be in those other areas. Slingshot has a set of AI tools that are touching on those capabilities, true AI capabilities. And it's a really exciting space to work.
So then explain to us how AI plays a role in space domain awareness.
Sure. Space situational awareness, space domain awareness it's complicated. There's a lot of information, a lot of data streams that are out there. There is a growing number of objects that are out there. Slingshot has developed the DARPA AI system, which is one of our solutions for the government to help with space domain awareness. We worked with DARPA on a project. We announced that in June, that the system was intended to detect anomalous satellites. And that might sound like something that we could do with computers before, or that might have been simple before. But the challenge was that we're seeing new constellations of satellites go up. Multiple constellations of 10,000 or more satellites go up by the United States, but also by international partners and competitors, and that potentially some of the satellites hidden within those constellations could have nefarious motives. They could be carrying hidden payloads and literally acting as if they're one of those satellites in those constellations. The amount of data associated with those constellations, if we're observing them with sensors, is huge. And historically, we might have had people evaluating those data. How bright are all the satellites? Are they maneuvering the way we would expect? Is one of them different from the other? But when we start to talk about tens of thousands of satellites that are doing much more in space than they have before, the amount of information becomes overwhelming, not just for one person, but for all the people we could throw at it. So AI does a great job of taking many data streams and sifting through those and building representations that are useful for people to think about. The Agatha system does exactly that. It has the ability to look at many data streams, whatever we throw at it, and it will evaluate and identify sets of objects that should be cooperating. And if there's one of them that seems to be a little different, it'll flag that for further investigation. So in general, there's sort of a scaling aspect to it. I think there's also a behavior aspect to it.
Okay.
Yeah.
Well, and I didn't mean to cut you off, but when you talk about an anomalous satellite, are you talking about something that if let's say unfriendly government was putting up a constellation of satellites, they might put one up there that looks like it's part of the constellation, but has a different function. And then the other thing is that could somebody put a satellite up into a commercial constellation that doesn't belong there, but it's really tough to detect? Is that the kind of thing you're talking about with an anomalous satellite?
Sure. So you can imagine you can hide something by making it invisible, or you can hide something by hiding it in the open and making it look like everybody else.
Sure.
And that cryptic satellite could be carrying jamming equipment. It could be carrying, it could be carrying what other sorts of things that we've seen in the press, and maybe pretending like it is one of the satellites that is, say, a communications satellite, or it's relaying information for the public or internet or whatever, but really it might have an ulterior motive.
Let's move on to the other aspect of this, and this kind of goes into the whole thing about the user interface on the track system, but how does AI then enhance space traffic coordination?
Absolutely. It's also one of those situations where we have more and more information that's coming around right now from all of these sensors. We recently published a paper at the AMOS conference, the Advanced Maui Optical Space Surveillance and Technology Conference, where my team put together both machine learning and AI techniques and the physics-based astrodynamics techniques that would have been looked at for conjunction analysis. And we found that the inclusion of AI and the inclusion of machine learning into that process of evaluating space traffic helped us identify conjunctions, potential collisions that were coming that would benefit from additional sensor tasking. So we could gather a little bit more information on those and improve safety by really focusing on the dangerous ones with the limited sensor resources that we have. I think there's lots of other situations where we have tons of data coming down for traffic coordination, and AI is going to be a piece of that.
You know, you mentioned AI and machine learning, and a lot of people use those terms interchangeably. What's the difference between AI and machine learning?
I think machine learning, and this would be my opinion, and others might have different opinions. Machine learning had very much emerged from a lot of the early maybe statistics work, representational models that would make predictions about particular events. AI plays into that and moves maybe beyond that. In many cases, the machine learning models are also particularly explainable. We can go in and we can look at what the mechanisms are in the math that provide the predictions that come forward. When we move into neural networks and some of the more advanced techniques explaining why those answers come out of those models becomes more difficult. And when we get into AI and the models are literally doing reasoning now, then they explain to us why they're reasoning. But how they get to that is maybe even more challenging from that aspect. But again, doing the things that humans are doing is that AI side of it.
What are the benefits then for using AI for satellite operations? What does your customer gain from using the Slingshot system or any AI system?
The complexity of space operations is increasing exponentially with the planned number of satellites and constellations that are going up. You see numbers that say, there are applications for 100,000 satellites in the next 10 years.
Right.
We know multiple constellations of 10,000 plus satellites are going up. So the complexity of those operations in those environments, both operating any one of those constellations or operating an environment with those constellations is infinitely more complex. Human controllers, which a lot of satellites are controlled by operators on the ground, don't scale particularly well when you start to talk about tens of thousands of objects that need to coordinate with each other and then with the other objects that are out there. AI does a great job of being able to work rationally with huge amounts of information. And so I think we'll see more and more AI come in there to help with that.
Is there a critical mass at some point where the technology as it exists currently can't keep up, or is the AI technology going to be able to keep pace with the number of satellites that are going into orbit?
The systems that we're developing with AI, I think, apply across a lot of domains, and space is phenomenally complicated and is a great place for AI to be working, but it may not be the most complicated place when we think about data packets moving around on the internet or shipping or signals, which AI is involved in all of those. And some of the same systems are involved with those as they might be in space operations. We can benefit from that. And at Slingshot, one of the things that we do is we try in our development of our AI to make sure that it has potential to plug in across domains, but that we can draw from the information and the developments that are in other domains as well. So I think space is a great application of it. And I think it actually benefits from AI development in, say, healthcare or genomics or those other areas as well.
I'm talking with Dylan Kesler, VP of AI and Data Science at Slingshot Aerospace on the Ex Terra Podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Dylan, what are some of the biggest challenges in implementing AI in space operations?
I think some of the biggest challenges right now in implementing it in space operations might come down to the speed at which space operations are increasing. Literally a few years ago, we're talking about a few thousand objects, and now we're talking about tens of thousands of objects, and proving out the AI that's going to be put into those places and moving it into those places is a challenge as well. From the ground, we're scrambling as fast as we can to do things like build sensors and build networks to track what's happening in space and put the AI in there. Honestly, the speed of development is one of those places. At the same time, though, we're seeing, literally, if we would have talked about this a year ago, we would have defined AI differently and envisioned how it might have been involved in space very differently. So AI is advancing very quickly too. As fast as we can, we're putting those systems into place.
When I talked with the folks at the Office of Space Commerce about tracks, and we'll get to that in a moment, but I made the analogy of air traffic control where their primary function is keeping the blips from bumping. And that's kind of what we're talking about with tracks. But who does AI make the decision, or does it just inform the decision as to who gets out of the way?
I want to talk about that synergy that we have at Slingshot with the folks from astrodynamics and physics and signals and data science. And historically, that would have been a question that we would have asked the Astro crews to think about, because it was very physics oriented. And when objects went up, they maneuvered maybe once a month. Ryan Shepard did a nice paper at Amos in a presentation where he showed how Iridium historically was maneuvering once a month, and then it's physics after that, and so you can see where the objects are going, and that how their satellites are now maneuvering almost daily. When you go from physics, predictions of how things are going to move, to behaviors when they're maneuvering daily and making decisions, then we move into a situation where you go from physics to AI, and the linkage of those two is important. Data science and AI deals with behaviors, so the satellites are behaving. The same maybe applies to your question of who makes the decision. Historically, it would have been a decision about where we predict this object is going to go and the uncertainty of it and how those are going to intercept. As we go forward, there's going to be a question of, and do we expect it to behave differently as it approaches a potential conjunction or an event in the future? When we get to the ethics of who makes that decision, right now, obviously, there's a lot of information out there, but humans are in the loop with all of these decisions. The White House gave a nice release recently on the ethics of using AI and where it should be. But at the same time, we see the government embracing AI and technologies and wanting to bring those into decisions. But what's interesting to me is that I think we might ask the same question in 10 years. Is it ethical to make a decision without AI in the loop? Is it a reasonable decision if we haven't had an AI analyst think about this and provide its recommendation?
That's an interesting concept. That can we do it without the computers? I don't know if I'm ready for that yet, Dylan. I guess we'll kind of wait and find out. Let's talk a little bit about a couple of specific things. You mentioned the project with DARPA and Agatha. What is Agatha and what's its importance?
Yeah, so Agatha is the product that came out of of the project that we had with DARPA, which was called Precog, sort of based on the 1992 movie, The Minority Report. But the idea that we can use AI to interpret the many data streams that are coming down and to look for potentially nefarious satellites hidden in constellations. So a wolf in sheep's clothing, as we talked about earlier. And that was the challenge. The team tackled that challenge, and we used Slingshot's systems, one of which is a physics true simulation environment, which I think is something else that's interesting to space, is that we end up doing a lot of simulation. And the reason we had to do that is because we were really challenged to build a system that could work or detect things that haven't occurred yet, maybe plausible events. And this applies across all of space industry. We're all envisioning, working on things that we've never seen before. So we had to simulate those. We needed 60 years of constellation data. Well, we haven't had satellite constellations for 60 years, and we needed them doing nefarious things in order to train our AI models. So we simulated that, and we built the Agatha system to detect within those simulated constellations whether there were specific actors that were doing things that were nefarious. Now, the AI didn't know that, and it detected those. And then we had to cross that sim to real gap, which is the idea that we've developed this thing in simulation. Is it going to work in the real world? Right. And so we applied it to real constellation data, and we found individual satellites that were differing within those constellations. And we talked to the owner operators, and those particular satellites might have been changing. They weren't nefarious, but they might have been changing mission, but they were certainly operating differently. They might have been suffering faults. They were operating differently from those. So we felt confident that it could be applied to real world data as well. So in the end, we have a system that we currently are running on our GSN sensor network data, which includes both the astrodynamic data, and we have photometric data coming in. So new data streams. We also incorporate the Sarah data database and its contextual data into that. And so we're running that internally. We get flags on satellites that we look at. We think it's very interesting. We're working with government partners who have numerous data streams, and they may be able to implement Agatha to identify satellites and constellations that may be challenges. It also has potential commercial application. I think commercial operators are all operating in space, and they're operating with other satellites that are out there, and they would like information about those as well.
Let's talk then about the TRAX user interface a little bit, too, because you were selected, and that's a good contract, and congratulations on that. But what can you tell us about what users and folks who are going to be using that TRAX program will see when they go and use that user interface?
Absolutely. Yeah. As you said, Slingshot was selected for the TRAX program. It was really exciting for everybody in the company and the others that are working on that. Last Tuesday, it's a $13 million contract by NOAA to build the user interface, the TRAX user interface. Slingshot was selected to build that presentation layer, and it relies or it leverages our Beacon software, which is something that we've been working on for multiple years, which was specifically designed to provide information about conjunction management. So this is a really great home for it. So we have the Beacon software that is in there that'll be servicing the conjunction data messages that are provided by the government there, the warnings about potential conjunctions that or potential collisions that satellites could have. And those are numbering more and more recently. So the TRAX system is going to be the place where the public can come in and to see that. The infrastructure we'll be supporting with ComSpock also, and with TNT Consulting Services, and this is also an extension of some of the work that we've done with the Office of Space Commerce as well. They did a limited Pathfinder projects earlier in the year, which we also participated in.
I think about when you watch a spy movie or something, and somebody always says, well, we'll just move a satellite over and get a picture of that. I don't know how realistic that actually is, but obviously, I think it's probably, if it's not happening right now, and it may very well may be, that it's coming in the not too distant future. How does the AI, where do you get the data if somebody's going to move a satellite into a different orbit? How do you get that data and incorporate it into the AI model?
For the AI model for space situational awareness, is a little different from, I think, the system that the government is building. In the system the government is building, it has lots of inputs from government sensors, but also the participants can submit their data as well. So participating companies will provide information about their operations to inform the track system as well. If it is a company or a government that's moving satellites, those are tracked by the many sensors that the government has, and then also sensors that companies like Slingshot has with our electro-optical network. And it's kind of interesting to me when I began working in this industry that we don't always know where all of those satellites are, and that it's a fairly major task tracking those and keeping track of all of them. It is a government scale task, or it is a big company scale task. We invest an awful lot in that. The AI comes into that when those satellites depart from physics, when they start to move, and they maneuver and their behaviors. And we're seeing more and more of that. As I said, some companies are maneuvering maybe every day, which means it moved away from where our physics predictions thought it would have been through propagation, and it moved somewhere else, and we have to go look for it somewhere else. And that uncertainty is exactly the kind of uncertainty that AI works great with. It can see the history of how those events have played out, and it can use that to make predictions about where we can look for those, or the behaviors, predict the behaviors even before they happen.
When you look at things like the X-37 program, which is the program where they basically put a spacecraft up and don't want people to know where it is, are you able to track those things as well?
I don't know specifically about the X-37 whether we're able to track that. They put it up, and I'll bet you that there are lots and lots of sensor operators that are looking for those objects when they put them up. There are a number of objects that I think everybody sees, and we don't always know what they are. And maybe they're lost objects, which are rediscovered frequently, which is kind of exciting. Maybe those are hidden objects too.
I think that's probably a point of pride is, oh, look, I found X-37.
Probably.
Just a couple of things more, Dylan. Let's talk a little bit about how AI is currently helping right now in real-world space missions and operations.
Yeah, we already see a level of autonomy in space operations. And in that simple level of autonomy, satellites can get conjunction data messages and automatically respond to those so that there aren't collisions. They can maneuver, so they maneuver out of the way. And as I said, those maneuvers are happening more and more now. And so we really need to shift from maybe an automated system that might work on a decision tree to moving to a more adaptable automated system where those satellites are going to be operating and maneuvering to keep themselves safe with more intelligent models. And those might move from physics-based to decision tree-based to AI-based. And I think we're going to see that to maintain safety, conjunction avoidance, or to maintain operations when there are lags in communications, when communications are denied, or when there are faults. Having AI on those spacecraft to take control of those is going to be important. That's in those space operations themselves as well as on the ground. So we have all the sensors and we're modeling space situational awareness. AI is going to be the layer that can interpret those many streams of data that are coming in and provide that awareness for operators about their craft and about the other craft that are out there as well.
Which kind of leads me into my last question, and it's the one that we ask of all of our guests, and that is to look ahead some 10 to 15 years thinking about space commerce and the role that AI might play in that, and tell me what you see.
Yeah. That might be similar to asking somebody 30 years ago, obviously not on a podcast, but 30 years ago, maybe you could ask somebody the role of the internet and communications, or advanced sensors in healthcare, or the role of handheld phones and connectivity. What might that be in 10 to 15 years? And I think that answer is exactly what I would say when you talk about AI in space. It's indispensable. Same answer. AI will be indispensable for space commerce and operations, for safety, for productivity, for efficiency, for security. I can see some of those technologies that we're developing at Slingshot that are on the cutting edge. They're really exciting, and you can see solutions in them, and those are coming around. And we're working on plans for things that we would like to see in the 20s and 30s. And so we can see that stuff coming around. And it's going to be integral to space operations, but it's also relieving and exciting because it's going to improve efficiency and safety.
Well, you might think that Gene Roddenberry was able to come up with some of those ideas 40 or 50 years ago for handheld communications devices and tablets and sensors and such. So who knows, you might be right. Dylan, we are out of time. Thank you so much. I really appreciate your time today.
Thanks, Tom. It was an honor to be here.
Dylan Kesler is VP of AI and Data Science at Slingshot Aerospace. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at XterraJSC. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo through his looking glass. Thirst for reason. Our dreamer's eyes we gaze into a sense of purpose known by few. Like finding water on the moon.